All right, welcome to the deep dive. Today, we're going to dig into this really interesting article. It's by Suraj Singh, and it's on Medium from March 2025. And he goes through this whole process of building an app. He calls it HeartApp, and the app is powered by AI, and it's designed to predict heart disease.
Yeah, I mean, the thing that really struck me about this article was just how much AI-assisted coding he was using. It's not just about like this one specific app. It really gives you a glimpse into how AI is really changing the way software and machine learning models are developed.
Right. It's like a shortcut to being well informed. If you're interested in the stuff, but you don't necessarily have the time to go deep into all the technical details, this is a great way to get a good sense of what's going on.
Definitely. And it's really interesting because, a lot of people, they hear machine learning and they think, oh, that's way too complicated for me. I need years of specialized training to even get started. But Suraj's experience really shows that AI can actually simplify a lot of these processes.
Yeah, it makes it feel a lot more within reach, right? Like maybe, I could actually build something like this.
Exactly. And what's even more interesting is that Suraj's background is actually in cybersecurity. I mean, cybersecurity is a challenging field, in its own right. And he even says, at first, diving into machine learning, it felt a bit out of reach for him. But then he discovered these AI tools, and it changed everything.
Wow, yeah, that really highlights how AI can bridge knowledge gaps, right? So, let's get into the details of HeartApp. How did this whole project, how did it even get started? What was the motivation behind it?
Well, Suraj talks about how the idea for HeartApp kind of came about through his doctoral research. Back in January 2025, he was, experimenting with different machine learning models, just kind of seeing what he could do with them. It wasn't about, launching a finished product right away, more like proof of concept.
Okay, so testing the waters, seeing what's possible.
Exactly. The basic idea was to create an app that could, take user data and then use that to predict, how likely that person is to develop heart disease. But what's really amazing is, think about how much work, how much time it would normally take to build something like this using traditional methods. And then think about how AI-assisted coding basically allowed Suraj to streamline that entire process.
Right. So let's dig into that a little bit. How did AI actually help him build HeartApp? What were the specific ways it was involved?
Well, Suraj points to three main areas where AI played a crucial role. First, there's code generation. He was using AI-powered tools, specifically GitHub Copilot within VS Code, to actually generate chunks of the core logic for the machine learning model. He calls it an augmentation tool, which I think is a really good way to put it. It's not replacing the developer, it's just amplifying their abilities.
Okay, so instead of, coding every single line from scratch, the AI is basically helping him get a head start.
Exactly. And it's not just about writing new code. AI also helped with debugging and optimization. Tools like GitHub Copilot were giving him suggestions for fixing errors and also for improving performance. Suraj even talks about how he deliberately introduced some errors into his code just to see how Copilot would respond.
Oh, that's interesting, yeah.
And it successfully guided him to the solution. So it's not just a theoretical thing. It's actually helping him solve real world problems.
Yeah, it's a practical demonstration of the capabilities.
Exactly. And then the third area where AI was really helpful was automated documentation. It was actually creating clear explanations within the code itself, which makes it much easier to understand how things work and to make changes later on.
Wow. So it's not just coding, it's also helping Suraj understand the code better, right?
Right. Now, you mentioned earlier prompt engineering.
Yeah, can you explain what that is exactly?
Yeah. So basically, prompt engineering is all about giving the AI the right instructions. You have to tell it what you want it to do, right? And the way you do that is by giving it specific prompts. Suraj's first prompt, it might seem simple, but it actually shows that he already had a good understanding of the basics of machine learning. He told the AI to use a specific library called scikit-learn and to get the data from Kaggle, which is a popular website for machine learning datasets.
Okay, so even though AI can do a lot of the heavy lifting, you still need to have some foundational knowledge, right?
Absolutely. It's like giving directions to a very capable assistant, right? Now, Suraj also used another AI tool, which he calls a prompt engineering GPT. This tool basically took his initial prompt and made it even more specific and detailed.
Okay.
When he used this refined prompt within VS Code in a Jupyter Notebook environment, it generated code that was practically ready to go. He just had to hit, accept and run and choose the right computing environment, and the AI did the rest.
That's pretty impressive. So let's talk about like the actual machine learning model itself. What were the main steps involved in building it?
So the first step is data preparation, right? Suraj mentions using some key libraries for this. Pandas for working with data, scikit-learn for the machine learning algorithms, and NumPy for like numerical operations. And then he got the heart disease data from Kaggle. That's from a user called John Smith 88, and it's in a CSV file, which is like a very common format for storing data.
Okay.
So once he had the data, he had to do some pre-processing. First, he had to handle missing values using a function called dropna. Sometimes data is incomplete, so you have to figure out what to do with those missing pieces. Then he had to encode some of the features that were categorical, like sex and key-p, which stands for chest pain type. These features were originally text, like male or female, and he had to convert them to numbers because machine learning models usually work with numerical data.
Right. And he used something called label encoder for that, right?
Exactly. Then he separated the features, which he called X, from the target variable, which was target, and he called that Y. Got it. So the features are all the different pieces of information that the model will use to make a prediction, and the target variable is what we're trying to predict whether the person has heart disease or not.
Okay. So what happens next?
Well, after that, Suraj did something called feature scaling, using a tool called standard scaler. This is basically making sure that all the features are on a similar scale, so that one feature doesn't have more influence than another just because it has larger values. And then the last step in data preparation was splitting the data into a training set, which was 80% of the data, and a testing set, which was 20%. The training set is used to teach the model, and the testing set is used to see how well the model has learned. He also mentions setting a random state with a value of 42. That just ensures that the data is always split in the same way, so we can get reproducible results.
Okay, so the data's prepped, it's ready to go. What about the model training itself? What models did he use?
So Suraj tried out 3 different classification models: logistic regression, decision trees, and random forests.
And these are all algorithms that can predict which category something belongs to, right? Like in this case, whether or not someone has heart disease.
Right. And to figure out which model was the best, he used several different metrics. Accuracy, which tells you how often the model is correct overall. Precision, which tells you how good the model is at avoiding false positives. Recall, which is how good it is at finding all the actual positives. And F1 score, which kind of combines precision and recall into a single score. And based on these metrics, the random forest model performed the best.
The article even has snippets of the code, like the code for importing the libraries, loading the data, preparing it, and training each of the 3 models.
Right. It just gives you a high-level overview, without getting bogged down in too much detail. He also mentions using a function called evaluate model, which probably calculated and displayed those metrics. And as he said, random forest had the highest F1 score, so that was the one he went with.
Got it. And then what about feature importance? What did he learn from that?
So feature importance basically tells you which features were the most important for making predictions. And in this case, he found that P, which is chest pain, K, which is the number of major blood vessels, and thalach, which is the maximum heart rate achieved, those were some of the most important features.
Interesting.
He points people to the Kaggle heart disease data set for more information about those features, which is, a good resource.
Right, yeah. So, okay, the model's built, it's trained, it's evaluated. What happens next?
The next step is saving the best model, right? And this is another area where AI was really helpful. Suraj just told GitHub Copilot, modify the code to save the best model after evaluation. And boom, Copilot just added the code using a library called joblib to save that trained random forest model into a file called randomforestmodel.pkl. So now he can just load that model later on without having to go through the whole training process again.
Right, okay, that makes sense. So he's got the model, he's saved it. Now, how do you actually make HeartApp usable? How do you deploy it so people can actually use it?
So for deployment, Suraj decided to create a web service. He used Flask, which is a Python framework for building web apps. It's pretty lightweight and easy to use, which makes it a good choice for something like this. And for this initial test, he just set up the Flask app on his local machine, the same one he was using for development.
Okay, so it was running locally on his own computer. So how did he actually create the system for getting predictions?
He created an API endpoint at an address called predict, and this endpoint accepts ppost requests with data in JSON format. So basically, you send a request to this endpoint with the patient's data in JSON format, and then the Flask app takes that data, transforms it into a format that the machine learning model can understand, and then feeds it into that saved random forest model to get a prediction. And then it sends the prediction back, also in JSON format. It's probably just a 0 or 1, indicating whether heart disease is present or not. He also mentions that he included some error handling just to catch any potential issues.
The article actually shows the code snippets for setting up the Flask app, loading the model, defining the feature names, and the code for that predict endpoint.
Yeah, it's pretty cool to see how it all comes together.
Yeah.
And he mentions using, app.run, debug true, start the Flask app, which is, pretty standard.
So how would someone actually use this predict API? Like, how would they send a request and get a prediction?
Well, they would send a post request to that predict endpoint with the patient's data in JSON format in the body of the request. And then the server would process that request and send back a JSON response with the prediction.
Okay.
He mentions using tools like Postman or Python's requests library for this. And for his own testing, he actually just used the command line within his VS Code terminal.
Oh, interesting. He also provides an example of Python code, showing how to structure the JSON data with fields like age, sex, OP, all those features the model was trained on.
Right. It's just to illustrate how you would actually interact with the API.
Yeah.
And he also includes some screenshots of a really basic HeartApp demo showing predictions on some synthetic data just to show how it all works in practice.
Cool. So at the end of the article, what were Suraj's main takeaways? What were his key points?
Well, he really emphasized the importance of AI-assisted coding. He sees it as this powerful coding assistant that makes development so much easier and more efficient. He talks about the rapid prototyping capabilities, how AI allows you to quickly create initial versions of your apps and then iterate on them.
Mm-hmm.
And he also highlights how this approach makes machine learning development more accessible to people who don't necessarily have a traditional machine learning background.
Right. So it's not just about making things faster. It's about making them more accessible.
Exactly. It's really about empowering people.
Yeah.
Giving them the tools to do more. As Suraj himself says, the future of artificial intelligence is not about man versus machine, but rather man with machine.
Yeah, that's a great quote. So just to wrap up our deep dive into Suraj Singh's HeartApp project, we've seen how he used AI-assisted coding, specifically GitHub Copilot, to streamline the process of building a machine learning app for predicting heart disease. AI helped him with code generation, debugging, optimization, even documentation. This approach enabled him to rapidly prototype his app, and it made machine learning development more accessible, even without extensive prior experience.
Exactly. And for everyone listening, think about this. This example shows a really clear path to rapidly learning about and applying complex technologies. It's about more than just reading a textbook or watching a video. It's about actually doing it right.
Right. And that brings us to our final thought for today. Consider this. As AI tools become more and more readily available, how will this change who gets to be an innovator? What will happen when people with deep knowledge in their respective fields, whether it's healthcare, education, whatever, what will happen when they have access to AI-powered development tools that can help them build solutions, even if they don't have a traditional coding or machine learning background?
It's exciting to think about, and I'm personally excited to see what kind of amazing things people will create. Thanks for listening.
Thanks for joining us on The Deep Dive.